Hi everyone, welcome to goclasses. In this lecture, we will study the next intermediate representation, which is static single assignment. So SSA, in short, we will call it SSA. Okay, so let's see what is this intermediate representation. Before this SSA, we have already seen an intermediate representation, which is three address code. Yes or no? So three address code, that is also intermediate representation. And remember, this SSA, this is another intermediate representation. Okay, so we have already seen what is three address code. Now in this lecture, we will see what is static single assignment form. Okay, so this is a intermediate representation. Now let's see what is this. The name itself is telling you the definition of SSA. Okay, look at the name. The name has two things. There are two things here. One is static, another is single assignment. Okay, single assignment means only one assignment, and the another is static. So remember, the name itself is telling you the definition. What is static? What static means? Let me tell you. Static simply means what static means. Let me tell you. Static simply means in the program text. Static means in the program text. In the program text. Is this clear? So this is important. Look at this. In the program text. Okay, means your program that you have written in the source program, I can say. In the program text, this is your source program. So in the source program. Okay, so this static means in the program text. And what single assignment means? That is very simple. Single assignment means every variable has only one assignment. Okay, so remember, every variable has only one assignment. Every variable, okay, whatever variable you take, every variable has only one assignment. Only one assignment. Only one assignment. Okay, so now you combine these two. Static means in the program text. Single assignment means every variable has only one assignment. Now you combine these two. What you will get? What the definition you will get? Tell me. The definition will be in the program text, every variable has single assignment. Okay, is this clear? In the program text, in your source program, the program that you are writing, in the source program, or I can say in the program text, every variable has only one assignment. Is this clear? So this is the definition you will get. You can notice that static means in the program text. Okay, this is static, this word means in the program text. Okay, is this clear? And this single assignment, what it means? It means that each variable, every variable is assigned only once. Each variable is assigned only once. So very simple point. Okay, now let's see what is assignment. Tell me what is assignment versus use. What is assignment? What is assignment and what is use? Let's see. So let's see what is assignment. Do you understand what is assignment versus what is use of a variable? Okay, assignment of a variable versus use of a variable. This is a very simple point. What is assignment of a variable that you already know? For example, in X, if I am assigning some value, maybe I'm assigning Y plus 1. So I can say this instruction is assignment of X. Yes or no? What I will say in this instruction, what we are doing, tell me. We are using X or we are assigning to X? Please tell me. In this instruction, we are using X or we are assigning to X? So in this instruction, you can see X is assigned. Yes or no? X is assigned. Is this clear? Okay, X is assigned. Is this clear? Let me know. So you can very easily see this instruction means X is assigned. For example, if I give you this instruction, Y equal to X plus 1. In this instruction, we are using X. Yes or no? X is used. X is not assigned. Here, X is used. I hope you understood. Is this clear? Please tell me. Let me know. And for example, if I give you this instruction, X equal to X plus 1. Here, X is assigned also. X is used also. Yes or no? So here you can notice that X is assigned also. In X, we are assigning also. X is assigned and used. Okay. So very simple. Remember, X is used and assigned. I can say first we are using this and then we are assigning this. So I can say first we are using, right? First we are using X. So X is used and then X is assigned. So is this clear? Is this point clear? What is assignment versus use of a variable? Okay. So tell me in the C language, if you focus on the C language, now in the C language, what is the assignment operator? Tell me which operator we use for assignment. In the C language, what is the assignment operator? For assignment, which operator we use? We use this operator, right? Yes or no? This operator we use in the C language for assignment. For example, in the C language, if I write like this, x equal to x plus 1, or I can say x equal to maybe a plus 1, then here you can notice what we are doing basically. This simply means x is assigned. Yes or no? It simply means that x is assigned. Okay. Is this clear? Please tell me. Now, you tell me few things I'm asking. Okay, few things I'm asking. For example, if I write this instruction, here x is assigned or x is used. In the C language, if I write this instruction, in the C language, if I write this, x is used or x is assigned. So here x is used, right? We are not assigning to x. We are not assigning to x. We are using x, because this means we are comparing x with 0. Yes or no? Basically, we are checking, is x equal to 0? Is x equal to 0? This means is x equal to 0? Is x equal to 0? Right? Yes or no? Is x equal to 0? So very simple point. So remember, here we are using x. And what about this one? If I write x plus plus, if I write this one, here we are using x or we are assigning to x? Please tell me. In this instruction, we are using x or we are assigning to x? First, we are using, then we are assigning, right? Yes or no? So we are using and assigning. We are assigning also, because we will increment, right? Okay, so we are assigning also. So here x is used as well as x is assigned. I hope you understood. So let's see the definition of static single assignment form. So remember, this is an intermediate representation. Please understand. This is an intermediate representation. We have already seen one intermediate representation. So this intermediate representation, how many we have already seen? Intermediate representations. Okay, so how many we have already seen? We have already seen three address code, right? Three address code that we have seen. Now another is SSA, static single assignment. This we need to study. Another that we will study, that is context free control flow graph, control flow graph. Okay. Another that we will study, that is a DAG and syntax tree. Okay. And syntax tree. So basically, these are some intermediate representations. There is postfix notation also that you study in the data structure, right? Yes or no? Okay, there is something called postfix notation. This you study in the data structure. Okay, this is already covered in data structure. In the data structure course, this is already covered. Okay, this you study there. So now we have already seen three address code. Now in this lecture, we will study static single assignment, SSA, static single assignment. So what is the definition of static single assignment? Static means in the program text. This is the meaning of static. If someone asks you what this static, what this word means, this word means in the program text. Okay. Next, single assignment. This means every variable has only one assignment. So you can see this is the definition. In the program text, every variable is assigned only once. Every variable is assigned only once. Very simple. Now, tell me the answer for this question. Which of the following program text is in SSA form? Two program text are given to you. This program. Which of them is in static single assignment form? Tell me. So you can easily see here x is assigned, here also x is assigned. Yes or no? Can you notice in this program? Look at this program. Can you notice here also x assigned? Here also your x is assigned, and here also x is assigned. Okay, so you can easily see that this is not in SSA. This is not in SSA form. Can I say that this is not in SSA form, right? Yes or no? For example, okay, so you can easily see this instruction, look at this instruction, look at this instruction. So x is assigned here also, x is assigned here also. So this instruction, I can say this program is not in SSA form. Is this clear? This program text, this is not in SSA form. What about this one? What about this one? Yes, this is in SSA form, right? Yes or no? This is in SSA form. This is in SSA form. Is this clear? Please tell me. Let me know. Is this understood? Here you can notice every variable you are assigning at most once. Look at every variable you are assigning at most once. Yes or no? look at any variable you are assigning at most once. I can say every variable assigned at most once. Every variable is assigned at most once. At most once. Okay, so this is the definition of SSA. Very simple point. Okay, now let's move on. What about this one? Can you convert this program into SSA form? First, you tell me right now, is this in SSA form? Right now, this program, is this in SSA form? Please tell me. This program is not in SSA form. This is assignment of I. This is also assignment of I. Yes or no? Here also we are assigning I. Here also you are assigning into variable I. And here also you are assigning variable I. Correct. Okay. So this program, this right now, this program is not in SSA form. So how to convert? How to convert this program in SSA form? Let's see that. Okay. So very easy to convert into SSA form. All you have to do, just change the name. Yes or no? Are you getting my point? See, here you are using variable I. Use a different variable here. Agree with me? Here you are using variable I. So use a different variable here. Okay. You can make a new variable. You can make a new variable basically. Or what you can do, just change the name. You can call it I1, you can call it I2. Yes or no? So very simple point. How to convert, how conversion of program text into SSA. Okay, how to do that? Very simple. Assign to a phrase variable every time. This is the simple point, right? Okay, assign to a phrase variable every time, assign to a new variable every time. So all you have to do, you can just change the names. Okay, so let me convert into SSA. All you have to do, just, okay, for example, you can call it I1. Okay, what you can do, you can call it I1. Now after some time, what you have, you have this I, this I, you have this I, you have this I, you have. Tell me one thing, tell me one thing, this I should be this one, right? Okay, which I is this? See, this is the use. Okay, yes or no? This is the use. There is no problem with use. You can use any number of times. You can use any number of times. Okay, any variable you can use any number of times. In SSA, only the assignment should happen at most once. Yes or no? So this is the use. So this variable we are using, right? This variable we are using. So let's call it I1. Okay. Assignment should happen at most once in the SSA. Static single assignment. Static single assignment. So you should not assign in this same variable you should not assign again. So what you should do, you can use a different variable I2. Okay, so you can call it I1, you can call it I2. This is the very simple idea. Okay, so now then what you can do, j equal to, now which I is this? Please tell me, which I is this, I1 or I2? Which I is this, I1 or I2? Yes, this is a I2. Yes or no? This is the use. Okay, so very simple. I hope you understood. Is this clear to everyone? Please tell me. So this is the idea, you can see. This is how you can convert into SSA, static single assignment. Okay. Is this clear? Very simple. Let's solve this one. Before we solve this one, let me tell you this word. See, SSA. Here, this means static. This means static. Static, what static means? Static means in program text. Okay, what static means? Static means in the program text. In the program text. In the program text. This is what static means. Now remember, this means single assignment. Okay, this means a single assignment. So use you can do any number of times. Agree with me? Yes or no? This is single assignment. Okay, assignment should happen at most once. Okay, so remember, to any assignment to any variable, assignment to any variable should happen at most once. Should happen once. Okay, at most once, at most once. Is this clear? So remember, assignment should happen at most once. Use, you can do any number of times. Okay, a variable can be used any number of times. A variable can be used any number of times. Any number of times. Number of times. Okay, so you can use it any number of times. There is no problem. Can be used any number of times. Is this clear? let me know. You can use it any number of times. So for example, if I write this type of program like I'm assigning this variable I'm assigning only once. Okay, let's assume I'm assigning only once. In the program, I'm assigning only once. Now I can use it any number of times. For example, I can use this here, I plus j. Okay, I can use this again, maybe I plus something, maybe k. Okay, right. Is this clear? So you can use this any number of times. There is no problem. You can again use I plus I. Okay, you can put in some other variable I2. So you can easily see that. I hope you understood this point, that you can use this any number of times. You can use this any number of times. So these are the uses of I1. This is a use of I1. This is the use of I1, right? Yes or no? Is this clear? So very simple. You can use any number of times, but you should assign at most once. Please tell me. You should change at most once. You should assign at most once, but you can use any number of times. Okay. So single assignment means every variable is assigned at most once. Okay. Now let's see this one. Convert this program into SSA form. Right now, is this in SSA form? Tell me. Right now, look at this and tell me, is this in SSA form? Is it in SSA form? Look at this and tell me, is it in the static single assignment form? So you can see P you are assigning here also, here also, here also, right? Okay, Q you are assigning here also, here also. So clearly this is a not in SSA form. Okay, so what to do then? What to do then? Okay, so very simple point. Conversion is very easy. Yes or no? Conversion to SSA is very easy. What you need to do? Assign to a phrase variable every time. Okay, yes or no? Just use a new variable for every assignment. For every assignment, use a new variable. Okay, yes or no? Just rename the solution, the conversion. For conversion, all you have to do, just use renaming. Okay, you can do the renaming. So just do assignment in a new variable every time. Assign to a new variable, to a fresh variable every time. So what you will do, tell me what you will do. Very simple. Let's call it P1. This new assignment, we will call it P2. This new assignment, we will call it P3. Yes or no? This new assignment, we will call it P3. Similarly, this assignment, let's call it Q1. This assignment, we will call Q2. Now it is very simple. Now, okay, see, this you are using here, right? So we will call it P1, right? Yes or no? Similarly, okay, where else can I say this is P1? Is this P1? Tell me, is this P1? No, this is not P1. This is P2. This is P2, right? This is P2. Okay, so this use is P2. Okay, similarly, you can see this is your P3. Is this clear? For example, you can see this will be your Q1. Correct. Agree with me. This is your Q1. I can say this is Q1. Is this clear or not? Let me know. So very simple. This is Q1 and then so on. What about this one? Is this Q1 or Q2? This Q. Is this Q1 or Q2? See, this is a Q1, right? Okay. Is this clear? Very simple. Because first we will use, then we will assign him. Okay, look at this instruction. In this instruction, first we use Q, then we assign into Q. Okay, look at this instruction. I am telling you, in this instruction, you notice, first we are using Q. Okay, then assign into Q. Then assign into Q. Okay, is this clear? So first you are using this Q. So basically this Q value you are using, right? Agree that this Q value you are basically using here. Okay, this Q value, this Q. Okay, so this Q is here. So this is what you are using here. I hope you understood. So is this clear? How to convert? Finally, this is your SSA. This is your 3 address code in SSA form. This is your 3 address code in SSA form. Please tell me, understood or not? So this is your 3 address code in the SSA form, static single assignment form. Let me know, did you understand? Please tell me. So very simple. This is your 3 address code and this is your static single assignment form. Like this you can do. I hope you understood. Now let's move on. Now let me tell you something. This is an important point. Okay. When we study compiler design, or I can say in the low level languages, define this word means assignment. Okay, remember define this word and this word, they are same. So please understand that when you study compiler design course, when you study code optimization or intermediate code representation, basically when you study compiler design course, in the compiler design course, remember, or I can say in the low level languages, or I can say in the intermediate representations, this word define, this simply means assign. Definition and assignment, these words are synonym to each other. Is this point clear? See, in your high level language, like for example C language, in C language, can I say define and assign, they are same? Can I say define and assign are same? No. Yes or no? In the C language, you will say that, sir, in the C language, we can define only once. We can assign any number of times, but we can define only once. Okay, for example, you can define only once, but you can use any number of times, something like that in the C language. Okay, maybe some concept you have, but I don't care about C language. I don't care about C language. Remember, in the compiler design course, or I can say in the low levels, okay, in intermediate representations, I can say in the intermediate representations, or I can say in the compiler design course, in compiler design course, these two words are same. You are defining a variable. This word is synonym to assign. Is this point clear? I will use this word many times. Define, define, define. That simply means assign. Definition means assignment. Okay, I will say this is the definition of variable. That simply means that is the assignment. That simply means that is the assignment. Is this clear? Please tell me, these two words, they are synonym to each other. For example, if I give you this code, let's assume I am doing this, I equal to a plus 1. So remember, here I am defining I. Then after some time, let's assume I am doing this. What I'm doing? I'm doing this, I equal to I plus 1. Here also I'm defining I. Is this clear? And let's assume after some time I do this, x plus y. Here also I'm defining I. So remember, I will say that in this instruction you are defining I. This instruction defines I. This instruction defines I. And remember, this is same as, I can say this instruction assigns I. Yes or no? Similarly, what I will say? I will say this instruction defines I. I will also say this instruction assigns I. Okay. What about this one? I will say this instruction defines I. I will also say this instruction assigns I. Is this clear? So these words are synonym to each other. Let me know, did you understand? So define a variable, that is same as assign a variable. So these two things are same. Define, assign. These two things are same, synonym to each other. Okay, I hope you understood. So very simple. The term define, that is same as the term assignment. So you can see the term assignment means variable definition. Okay, is this clear? The term assignment, that means variable definition. So very easily, you can see here you are assigning to x, yes or no? So I can say you are defining x. Okay, I can say the variable x is being assigned, or I can say the variable x is being defined. You can say assigned also, you can say defined also. Okay, you can say assigned also, you can say defined also. So you can see this is a definition or assignment. Okay, is this clear? Let me know. Now let's move on. What about this instruction? What about this code? This program is given to you. This code, you tell me, is this code in the SSA form? Look at this code and tell me, is this in SSA form? I have given you this program. Okay, consider this program. Consider this program. Okay, so before I ask you that, tell me which instruction is defining and which instruction is using. Tell me. Look at this code and tell me which instruction is using and which instruction is defining. See, look at this instruction and tell me. Okay, my question, please understand my question. My question is, which instruction defines and which instruction uses? Which instruction defines and which instruction uses a variable? Please tell me. Let me know. Did you understand? I'm asking which instruction is defining, which instruction is using. For example, here you are assigning. So here you are defining x. In this instruction, look at this instruction. In this instruction, basically you are defining x. In X, you are putting some value. Some value you are putting, some input you are taking. Okay, remember, some input you are putting in X. So here you are basically assigning X. What you are doing here? Here you are assigning X. That is same as what? That is same as what? That is same as you are defining X. Okay, both are same. That is same as defining X. So you are defining X. What about this instruction? What about this instruction? Here you are using X. Yes or no? Here you are using X. We are not defining. Here we are using X. Yes or no? We are not defining X. We are not assigning X. I hope you understood. So you are just doing the comparison. Is X equal to 42? Is X equal to 42? Here you are defining Y. Yes or no? Here we are defining Y. Here also we are defining Y. Here also we are defining Y. Okay, is this clear? And what we are doing here, please tell me. And what we are doing here, we are using or defining? We are using Y. Okay, here we are using Y. We are not defining, we are not assigning, we are using Y. I hope you understood. Okay. Now let's see what this static word means. What this word means, right? This is a curious thing. See, this is very common sense, right? Single assignment. This word is very common sense. Agree with me? Yes or no? This is very simple. Single assignment. Single assignment means every variable has a single assignment. Every variable is assigned only once. But what is this mystery? Yes or no? You might be thinking, sir, what this word means? Like what this actually means? Why we are using this static word? Do you think? Yes or no? Are you curious? So what I told you, what this word means, I told you this word means in the program text. I told you this word means in the program text. Yes or no? So now let me explain what it means. Let me explain. So consider this example and tell me, is the following program is in SSA form? This following program, can I say this is in SSA form? Before you answer this question, understand one thing, that when you execute this, then is it possible that these two assignments can happen? Tell me, when you execute this program, how many assignments will happen for Y? When you execute this program, how many assignments will happen for Y? See, during execution, how many assignments will happen for Y? During execution, please understand, during execution, when you execute this program, during execution, Y is assigned only once. Y is assigned only once. Do you agree with me? Do you agree with me that when you execute this program, do you agree with me that Y is assigned only once? During the execution, Y is assigned only once, because this is if then. If X value is 42, okay, if X value is 42, if this is true, then this will happen. If this is true, then this will happen. And if this is false, then this will happen. Yes or no? So I can say that during the execution, Y is assigned only once. Y is assigned only once. So can I say this is in SSA form? When you execute this program, then this variable Y will be assigned only once. Yes or no? If X value is 42, if this is true, then this will happen. And if this value is false, then this will happen. Now my question is very simple. So can I say this program is in the static single assignment form? Can I say this is in the static single assignment form? Think about it. Let me know. Can I say this program is in the static single assignment form? And the answer is no. And the answer is very big no. Why? We don't care about execution. The name itself is telling you static single assignment. See, look at the full form. The full form is static single assignment. Okay, the full form is static single assignment. Yes or no? Is this clear? Please tell me. The full form is static single assignment. Let me know. Is this clear? Static single assignment. So we don't care about the dynamic things. What will happen with the execution, we don't care. The name is not dynamic single assignment. Yes or no? Execution means dynamic. Okay, see, if you are thinking about what will happen when you execute, execution simply means basically, okay, anything which is related to execution, that is dynamic. Let me tell you, dynamic, that means execution related. See, execution related things are dynamic. Okay, when you execute a program, then that comes under the category dynamic. Okay, actually, if you go to ISC, let me tell you, in the first semester there are two courses. One is static program analysis. Program analysis, and another is a dynamic program analysis. Let me tell you, these two courses are there in the first semester. I don't know now, but when I was in ISC from 2018 to 2020, then there were two courses in the first semester. Okay, these two courses in the first semester, ISC CSA first semester. At my time. Okay, so I took this course. This is what I took. Okay, let me tell you, in these two courses, what happens here? The program analysis happens on the text. Is this clear? Static means on text. The program analysis happens on the text. In this course, we don't run the program. Is this clear? Means we don't run the program. Is this point clear? We don't run the program. Let me know, is this point clear? The analysis happens on the text. And here the analysis happens dynamically, means analysis happens during execution. Is this clear? Please tell me, did you understand the difference between these two courses? You can check it out. In ISC CSA, first semester or second semester, these two courses are offered. Okay. So I took this course. This course is also called PAV. In short, this course is called PAV. This was the short name, Program Analysis Verification. But this was basically static program analysis. And there was another course which was dynamic analysis. Okay. So this is what I'm telling you. So remember, there are two types of analysis possible. One is static. Static means we don't run the program. We don't care about the execution. What happens during the execution, we don't care. Is this clear? During execution, how many assignments happen, we don't care. Is this clear? We don't care how many assignments happen during execution. Okay, static single assignment, that simply means in the text. Static, this word means in the text. In the program text. Just look at the text. Just look at the program text. Is this clear? In the program text, single assignment should happen. Okay, we don't care what happens during the execution. Please tell me, is this clear? This SSA does not care what happens during the execution. During the execution, any variable can be assigned infinite number of times. I don't care. But in the text, every variable should be assigned at most once. Now you tell me, look at this text and tell me. Don't run the program. Don't think about the execution of the program. Just look at this text. Look at this text. This text you look and tell me, is this in SSA? This is the text. Is this in SSA? Look at this text. Please tell me. No, this is not in SSA because you are assigning y more than once. Yes or no? So, is this clear? We are assigning y more than once. Please tell me, is this understood? Let me know. So, remember, static single assignment means that we are dealing with only program text. I hope you understood. Is this clear? Let me know. Okay, so please understand that. Let me write this here. That in the static single assignment, SSA means static single assignment. This SSA intermediate representation. This is the intermediate representation that you already know. Okay, SSA intermediate representation. This means static. Static single assignment. During the execution, what happens? We do not care. Is this clear? So static means on the program text, or I can say in the program text. In the program text. Is this clearly understood? Please tell me. See, tricky questions can be created if you do not understand this word. What this word means. What this word means. Okay, so static means in the program text. Just look at the program text. We don't care what happens during the runtime. Okay, is this clear? During the in the program text, single assignment should happen. Is this clear? So we do not care what happens during execution. We don't care about execution. We don't care about execution or runtime. We study static single assignment. We do not study dynamic single assignment, right? This is static single assignment. This is not dynamic single assignment. So I hope this word is clear now. The importance of this word, is that clear? Please tell me. The importance of static word, is that clear? So very simple. This is your static single assignment, that in the program text, you should have single assignment for every variable. Every variable should be assigned at most once. So very simple. So remember here, you can see, look at this. So this, because of this assignment to assignment, this is your assign. Here also we are assigning y, and here also you are assigning y. Okay, so that is the reason this code is not in SSA. Not in SSA form. This program is not in SSA form. I hope you understood. Okay, now let's move on. So very simple, what this static word, what this means. The term static, this indicates that SSA relates to properties and analysis of program text. Is this clear? Okay, SSA is basically related to properties and analysis of program text, program code. Now, let me ask you this another question, another beautiful question. If a program is in SSA form, every variable is assigned only once in the program text. Can we have a loop in the program which is in SSA form? Okay, let me explain this question to you, then you answer this question. First, let me explain this question. See, if you have a loop, then what will happen? Just notice. Let's assume you have a program which is in SSA. Okay, let's assume you have a program which is in SSA. Now, let's assume you have a loop. Okay, there is some loop you have, and inside this loop, let's assume inside this loop you have this type of statement. For example, I equal to a plus b, something like that. Okay, or maybe I equal to I plus 1, something like that. Okay, is this clear? I equal to I plus 1. So this statement you have, I equal to I plus 1. Now you tell me, is this in SSA form? Basically the question is, can we have loop if your program is in SSA form? If your program is in SSA form, can we have a loop? See, what is the problem with loop? The problem with loop is when you execute this, then this assignment will happen many times. So can I say this is in SSA form? Are you getting my point? When you execute this, during execution, many assignments will happen. When you execute this loop, during execution, okay, many assignments to I. Okay, yes or no? Several assignments to I. Okay, first, this I will keep assigning. Yes or no? When you run this program, you are running this program, then what will happen? You are doing many assignments, assign. In every iteration, you are assigning. If this loop is running 1,000 times, then you are assigning 1,000 times. So during execution, several assignments, during execution, several assignments to I. So can I say this is an SSA? So can I say this program is in SSA? Is this program in SSA? Let me know. Please tell me. Is this program in SSA? Can I say this is in SSA? Is this program in SSA? Let me know. Is this program in SSA? So can we have loop if your program is in SSA? If your program is in SSA, can we have loop? Can we have this type of situation if your program is in SSA? Of course we can have loop. There is no problem here. Why are you running the program? I'm just confusing you. See, I'm just confusing you that during the execution, this assignment will happen many times. But we don't care about execution. The name is static. As for static, is this clear? Please tell me. Let me know. Are you getting this point? See, the name is static. Why I'm again and again telling you static, static, static. We don't care about execution. Yes or no? We do not care about execution. During the execution, assignment can happen any number of times. I don't care. During the execution, you can assign a variable 1,000 times, 1 crore times. I don't care. But in the program text, your program text, in the program text, every variable should be assigned only once. Is this point clear now? Again and again, I am telling you, one day in the GATE exam, a nice question will come. Don't make this mistake. So is this point clear now? So remember, static. This is static single assignment, means in the program text, just look at the text. We don't care about execution. Yes or no? So can we have a loop? The answer is of course. The answer is of course. Of course, yes. The answer is of course, yes. Who cares about execution? Yes or no? Is this an SSA? Again, the answer is yes. Who cares about execution? Right? Can I say during execution, who cares? During execution, who cares? Please tell me, understood now? Can you say that you understood this word static? Is this explanation clear to you? So remember, if a program is in SSA form, then can we have loop in the program? The answer is of course yes, no problem. Of course, yes, no problem. We don't care about execution. Okay, during execution, any number of assignments can happen. During execution, any number of assignments can happen to a variable. We don't care. Any number of assignments can happen to a variable. Any number of assignments can happen to a variable. Can happen to a variable. We do not care. Okay, in capitals you can write. We do not care. Is this understood? Is this point clear? Sorry, again I am telling you, static. The name is static single assignment. Okay. Now tell me, do you need more explanation of this word static? Static means in the program text. In the program text. Don't think about execution, just think about program text. Forget about execution. We do not care about execution. Okay, in the program text. Okay, yes or no? Forget about execution. Don't think about execution. Forget about execution. We don't care about execution. SSA doesn't care. Okay, because this is static. This happens only on the text. Okay, so that's it. I hope you understood this. So very simple point, remember, SSA, this is a new intermediate representation. We have already seen 3 address code, which was another intermediate representation. 3 address code was another intermediate representation. This is another intermediate representation. Both are different. Okay, some student was asking, are they same? No, they are not same. They are different. Okay, is this clear? The static single assignment, this is different. 3 address code is different. Okay, so you can see every variable has exactly one definition in the program text. So this word you notice in the program text, every variable has exactly one definition. Okay, this does not mean that there are no loops. I told you, yes or no? You can see this is a static single assignment, not dynamic. Okay, so this is what I told you. Okay, now let's move on. So we have seen everything. We have seen what is SSA. SSA means static single assignment. This is an intermediate representation where every variable is assigned at most once. Every variable is assigned at most once in the program text. Okay, all these things matter. Like this in the program text, every variable is assigned at most once. So very simple points. So you can see what is static single assignment. Okay, what is static single assignment? You can see that in the static single assignment form, every variable is defined. Defined or assigned, both are same, right? Yes or no? These two words are same. Defined or assigned, both are same. So you can see every variable you are assigning exactly once, but may be used multiple times. Okay, you can use it multiple times. You can use it many number of times. Okay, so very simple point. So you can see if this is your code, then you can convert into SSA. This code we can convert into SSA. Okay, very easily. All you have to do, just do the renaming. Yes or no? Assign to a fresh variable every time. Okay, so don't assign to the same variable more than one time. Don't assign to the same variable more than one time. Okay, just use different names. Yes or no? So assign to a new variable every time. Assign into a new variable every time. So for example, here you have A, here you have A, here you have A. So you can make it A1, A2, A3. You can make it A1, A2, A3, right? Yes or no? Similarly, here you have B. Okay, there is no problem with B. There is no problem with B. So you can just simply call it maybe B1. You can call it C1, no problem. Okay, there is no problem with B. You can just simply call it B1, C1. Okay, so very simple. Now you can see this A you are using here. So you will write it A1 here, right? Yes or no? So you are using here. Okay, so can you notice? Tell me, is the control flow changing? Let me know. Is the flow of execution changing? Okay, is the flow of execution changing? See, this B you are using here, no problem. This B you are using here. Okay, is the flow of execution changing or not? Flow of execution is not changing, right? Yes or no? See, flow of execution is not changing. Please understand. Okay, flow of execution is same. Agree with me or not? Yes or no? Is this point clear? See, flow of execution is everything is same. Flow of execution is same. Okay, so that is the point. So flow of execution does not change. Okay, whether you have this code or you take this code, the flow of execution is same. Okay, so flow of execution remains same. I can write here, flow of execution remains same. Flow of execution remains same. Remains same. Okay. Anyway, so let's move on now. So you can see SSA form, static single assignment form. Okay, this is a way of structuring the intermediate representation so that every variable is assigned only once. Okay, so very simple. So all these simple points we have already seen. This example we have already seen how to convert this code into static single assignment code that we have already seen. Now let's move on. Now let's solve this GATE exam question. Can you tell me what is the answer? This is GATE 2017 question. Consider the following intermediate program in 3 address code. Intermediate program is given to you in a 3 address code. This program is given to you. Which of the following corresponds to the static single assignment form of the above code? So which is correct answer? Let me know. Which of them is correct answer? Let's check each option one by one. Okay, let me check option A. So is option A correct static single assignment form corresponding to this given program? Okay. See, in this given program, you can notice this variable you are using here. Notice one thing, this variable you are using here. Okay, so first of all, this is not even in SSA. Option A. Option A is not even in SSA. You are assigning to P1. Yes or no? You are assigning to P1 more than once. We are assigning to P1 more than once. This variable P1, we are assigning more than once. So this is not even in SSA. Look at this here. Okay, this variable Q1 also you are assigning more than once. So very simple, this option A, this not even in SSA. This not even a SSA form. Because you can easily see SSA means static single assignment. Means every variable in the program text, every variable is assigned only once. Yes or no? So you can see this option A, this is not even SSA form. Because this variable P1, you are assigning more than once. This variable P1, you are assigning more than once. So this is not even in SSA. So this is wrong. What about option B? What is the problem with option B? What is the problem with option B? Is there any problem with option B? See, option B is saying P3, no problem. Okay, you can rename this P3, no problem. I can call it P3. Okay, P3 is equal to A minus B, no problem. You can call it Q4, there is no problem. Okay, now you can notice here this P you are using here, so you will use P3. Yeah, that is also fine. That is also fine. Then you are calling it P4. That is also fine. You can call it P4. Okay, P4 equal to U into V. That is also fine. Then you are calling it Q5. That is also fine. No problem. Yes or no? You can call it Q5. Renaming, basically you just need to rename the variables. You can give any name. You are renaming the variable. You can give any name. Now remember, this P you are using means P4 you should use. Means you should use P4. And remember, this Q4 you should use. Okay. So this is correct, right? This option B, this is actually correct answer. Yes or no? Option B is the correct answer. Is this clear? See, very simple point. Option B is actually the correct answer because, okay, let's convert this into SSA. Let me convert this into SSA. What SSA says? SSA says that every variable in this text, in the program text, every variable should have single assignment. Yes or no? To any variable, you should not assign more than once. Okay, so if you are assigning more than once, then just give different names. Yes or no? If you are assigning more than once, just give different names. Use renaming. Okay, so use phrase variable, or I can say phrase variables. Use free phrase variable for assignment. Very simple. So what you can do? I can call it P3. There is no problem. I can call it P1 also. You can call it whatever you want. This is just a different variable we are using. Okay, we are using a different variable. We are renaming the variable so that to any variable we do not have more than one assignment. Okay, so you can use P3, no problem. Now you can see here you should have P3. Okay, you should have P3. So very simple point, because this P you are using here, so you should have P3 into C. Okay, you can put that into Q4, no problem. Then next, then you are doing U into V. You can use a different variable here. You can use a different variable. You can say P4. And then finally, what you can do? You can use a different variable here. So you can use Q5 here. And this P must be this one. This P must be this one. So this must be P4 plus, and this Q, which Q? This is your this Q. Okay, this Q. So you can see this will be Q4. So finally, your answer is option B. I hope you understood. Is there any problem with option C? What is the problem with option C? Please tell me. Let me know. What is the problem with option C? Is there any problem with option C? Any problem with option C? Yes, there is a problem with option C. See, this is the problem. Agree or not? Here is the problem. Okay, because remember, you should use the same, this P you should use. Agree or not? You should use this P. Remember, this P you should use here. Okay, this P you should use here. This P you should use here. And similarly, this Q you should use here. Okay, so you can see there is a problem. So this is a not equivalent to the given program. Yes or no? This is not equivalent to given program. This is not equivalent to given program. What about this option D? Is there any problem with option D? Please tell me, do we have any problem with option D? Yes, again with D we have a problem. The same problem in the option D also. The same problem, you are using P1 here, you are using P here. You are using different variables. Yes or no? So this is the same problem. This is the same problem with option D. So finally your answer is option B. That's it. Okay, let's move on now. Now this is GATE 2016 question. Let's solve it. So remember, in GATE 2017, question came from SSA. Yes or no? Question came from SSA in 2017. In 2016 also, the question came from SSA. Okay, let me tell you, in 2016 and 2015 also, question came from SSA. So 2015, 2016, 2017, consecutively 3 years, the question on SSA came. And these are very simple questions. Okay, these are very simple, easy questions. So let's see. Consider the following code segment. This code segment is given to you. The minimum number of total variables which are required to convert the above code into static single assignment form. Okay, so let's convert this into SSA form, and then you count how many total variables are there. Yes or no? So just convert this code into SSA form, and then you count how many total variables are there. So let's calculate. Okay. So first you convert. First of all, you tell me, is this in SSA? This given code, is this in SSA form? No, this is not in SSA form, because you can notice that variable X you are assigning more than once. Yes or no? Variable Y you are assigning more than once. Yes or no? Agree? So variable X we are assigning more than once, and variable Y we are assigning more than once. So this given code, okay, this given code segment is not in SSA, right? Is not in SSA form. We have to convert this into SSA form. So let's see how to convert. Okay, let's convert into SSA. So what you will get? First, what you will get? Very simple. Just rename the variables. Okay, what is the idea? The idea is very simple. Just rename the variables. Just change the variable names. Use different variables for assignment. Okay, don't assign the same variable more than once. So use different variables, or you can rename the variables. For example, this variable X, I can call it X1. Yes or no? This variable X, I can call it X1, no problem. Okay, yes or no? So I can say this will be X1 equal to U minus T. So this different variable I can use. I'm using a different variable. Then what I'm doing, remember this is X1, right? Yes or no? This is X1 multiplied by V. Okay, because you can easily see the same X you are using here. We are using the same X here. So this will be X1 into V. And this you are putting into Y. So let's call that Y1. Okay. What else? Let me know. What will be the next? What you will do next? Tell me. So very simple. Then you can easily see Y plus W. Which Y is this? Which Y is this? So this is your, this Y. Yes or no? So this is Y1. So I can say this is Y1 plus W. And you are putting this into X2. You can use a different variable X2. Okay, then what you can do? Let me know. Then what you will do? Please tell me. Please tell me. So then what you are going to do? Very simple. T minus Z. T minus Z. Okay, you can assign this into a new variable. You can use a new variable. You can use maybe Y2. It does not matter. You can use Y3 also. Basically, you just use a different variable. Just use a different variable. You can use T2 also, no problem. You can use, for example, M2 also, no problem. You can use M also, no problem. Are you getting my point? Just use a different variable. Okay. So for simplicity, just use Y2. Then what you can do? Very simple. Then this is X into Y. So this Y is Y2. And which X is this? This is this X, right? Yes or no? So this is this X, means this is your X2. This is your X2. And you are putting this, you are assigning this to Y. So use a different variable, Y3. Tell me total how many variables? The question is asking total. So total how many variables are there? Please tell me. How many total variables? The question is asking how many total variables are required to convert the code segment into SSA form. Okay, so tell me how many total variables are there in this code? How many total variables we have? So let's read how many you have. Tell me. So you can see five variables you have here, XY. 5 variables are here, XY. Then UT. Okay, so see, total variables are these. These are the total variables. Let me write it. 5 variables are X1, X2, Y1, Y2, Y3. Y1, Y2, Y3. These are 5 variables. Then what you have? Then you have U, then you have T, then you have V, then you have W, then you have Z. Okay. So you can see U, V, W, Z, T. U, V, W, Z, T. Yes. So finally answer will be 10. Total variables will be 10. Is this clear? Please tell me. So very simple question, right? So the total variables that are required, that will be 10. Did you understand this? Let me know. Is this question clear to everyone? Please tell me. So the answer is going to be 10. Now, this is your 2015 question. Let's solve it. Did you notice one thing? That from SSA, the question came in 2015, in 2016, in 2017. Okay, 3 times consecutively, the question came from SSA. And this is a very easy topic, let me tell you. This is easy. Okay. In future also, if any question will come from SSA, I guarantee that you will be able to solve it. Okay. So let's solve this question. The question is saying the least number of temporary variables which are required. See, the question is asking the temporary variables. We are asking how many temporary variables are required to create a 3-address code in static single assignment form. You create a 3-address code in SSA form for this expression. This expression is given to you. So can you take your copy pen? Can you take your copy pen? Let's do it. So this expression is given to you: q plus r divided by 3 plus s minus t multiplied by 5 plus u multiplied by v divided by w. Okay, so this is the expression that is given to you. So let's solve it. First, what you do, you create 3-address code. Is this clear? What you do, you create a 3-address code in static single assignment form. So what we need to do, we need to create 3-address code in SSA form. This is what you need to create. Create 3-address code in SSA form. SSA form means don't assign same variable more than once. Yes or no? Static single assignment. Don't assign same variable more than once. Okay. And 3-address code you already know. So let's do that. So tell me, if you convert this into 3-address code, first what will happen? First, what will happen? Let me tell you something. First of all, let me tell you that these are arithmetic operators. What is their precedence? Do you know from your school life? Let me take you back to the school life. In the school life, you have already seen what is the precedence. See, you already know these operators. Multiplication and division, they have the same priority. Multiplication, division, they have same priority. Yes or no? They have same precedence, same priority. Okay. And they have more priority than addition, comma, subtraction. And addition, comma, subtraction have same priority. They have same priority. Yes or no? And also, for example, if you have this type of thing, okay, if you have this type of thing, then what we will do first? Division or multiplication? Here, what we will do first? Division or multiplication? Tell me. They have same priority. Multiplication, division, they have same priority. They have same priority. And when they have same priority, you do them left to right. The associativity is from left to right. Yes or no? Also, you do them left to right. Is this clear? Please tell me. So here what you will do? Here actually first you will do u into v. First you will do this, and okay, let's assume you put this into some variable. Okay, maybe let me just call maybe t4. Then what you will do? Then you will do t4 divided by w. Is this clear or not? Please tell me. Did you understand this point? Let me know. Is this point clear to everyone? This is from your school life. Understood? So remember, multiplication, comma, division, they have same priority, and we do them left to right. If they have same priority, we execute them from left to right. Next, these two, addition, comma, subtraction, they have same priority. We execute them left to right. Okay. So very simple point. Now let's come back to this question. So first, what will happen? Tell me. First, what you will do? Okay. So first you can do r divided by 3, because the highest priority, multiplication, comma, division, they have highest priority. So what you will do? You will do them left to right. So first you will do r divided by 3. Okay. You can do this r divided by 3. So let's solve it. So first you can do r divided by 3, and you can assign this to some variable t1. Okay. Some temporary variable t1 you can use. So very simple. Then now this is done. Okay. This is where this you have in t1. Is this clear? This you have in t1. Then what you will do? Please tell me. Then what the next thing you will do? Let me know. What will be the next thing that to do? That will be t into 5. Yes or no? This you will do t into 5. Okay. So very simple. Then you will do t. This t is not a temporary variable, right? This t is not a temporary variable. This t is not a temporary variable. See, this is temporary variable. This is your temporary variable. But this t is not a temporary variable. This is source program variable. Yes or no? Okay. This is a source program variable. source variable. Okay, source program variable, source code variable. So very simple. So you can see you will do t multiplied by 5, and you can store this into some other temporary variable t2. Okay, because you want SSA form, so don't assign into the same temporary variable more than once. Okay, so very simple. This is what you will do. Now this you have in t2. Finally, I can say this is what you have in t2. Next, what you will do? Tell me. Next, what you will do? Next, you will do u into v. Yes or no? Next, you are going to do u into v. This is what you are going to do. Okay, so just do this u into v, and you will put this into temporary variable t3. Yes or no? So just put in temporary variable t3. Then what you will do? Then what you are going to do? Then you are going to do t3 divided by w. Yes or no? T3, this t3 you are using t3 divided by w. You can store this into some temporary variable t4. Okay, yes or no? So very simple, because we want SSA form. You want a static single assignment form. So don't assign this to the same variable which you have already assigned. Don't assign this into the same variable which you have already assigned. Okay. Assignment to any variable will happen at most once. Okay. What about next? Now this is what you have in T4. Basically, I can say this is in your T4. Then what you will do? Tell me. What is the next thing to do? The next thing to do, that is only plus minus plus minus. So then you will do this. Okay. This you will do Q plus T1, and you will put this into T5. Then what you will do? Tell me. Now this is what you have. Remember, this is what you have in a. Now this is what you have in T5. In T5 you have this. Okay. Then what you will do? You will do T5 plus S. Yes or no? T5 plus T5 plus S. Very simple. So this you will put in T6. Okay. Now this is done. Then what you will do? Then what you are going to do? Then you are going to do T6 minus T2. Yes or no? Then you are going to do T6 minus T2. This you will put in T7. Okay. Is this clear? Then what you are going to do? After this, what you are going to do? Then you will do T7 plus T4, and this you will put in some other variable T8. So finally, that's it. So how many temporary variables are needed? The question is asking how many temporary variables are needed. Let me know. How many temporary variables are needed? The answer will be 8. Is this clear? The answer is going to be 8. I hope you understood. Is this clear or not? Please tell me. So very simple question, right? Agree or not? This is an extremely simple question. You can see now you have 3 address code in the SSA form, in the static single assignment form. So very simple question. The answer is going to be 8. This will be the final answer. The answer will be 8. Okay. So we have seen all the GATE exam questions. Each and every GATE exam questions we have done. So did you understand SSA? So far we have seen SSA. Also, we have done all the GATE exam questions. Are you confident in SSA? Static single assignment form. What this static means, what single assignment means, and what this together means. Static single assignment, what this means. How to convert a program into static single assignment form. So all these concepts and the GATE exam questions, are they clear? Please tell me. Are you confident in the static single assignment? Now I am going to teach you something which has not come in the GATE exam so far, but it will come in the GATE exam someday. Okay, basically now what I'm going to teach, that is part of SSA, that is given in every standard resource. You can study any standard resource. If you study SSA from any standard resource, okay, whatever book you study, whatever NPTEL lecture or whatever university article you study, the concepts that I will teach you now, those concepts will be given. But these concepts that I will teach you now, from these concepts in the GATE exam so far, there is no question. Okay. So that is the reason no coaching institute is teaching these concepts. Okay. So some students might be thinking that these are out of syllabus. No, these are in the syllabus, but let me tell you that the question will come in future. I guarantee. So the topics that I will teach you now, these are standard topics. Okay, remember, these are part of SSA. These are standard topics in every standard resource, in every book, in every university article, in every NPTEL lecture. You will find these topics. But In the coaching institutes, they will not teach. When they will teach? In the coaching institute, when they will teach? When the question will come in the GATE exam. Okay, so remember the topics that I will teach you now, these are for future GATE exam question. And I promise you one thing, in the future, okay, maybe after 2 years, maybe next year, maybe you will give the GATE exam, maybe in your year, or maybe after 2-3 years, the question will definitely come. Okay, let me tell you one thing. Actually, from this SSA, question came in 2015. This was the first question came from SSA. Okay, in 2015, the first question from SSA came. Question from SSA came. Is this clear? The first question from SSA came. Then in 2016, the question came. Then in 2017, the question came. So actually, let me tell you one thing. Okay. Before this, in the coaching institutes, they did not teach SSA. Okay, so let me tell you, before 2015, in the coaching institutes, they did not teach SSA, this static single assignment. Okay, but when the question came in the GATE exam, then they started teaching. Okay, they did not teach even here also. In 2015 also they did not teach. Means after 2015 also they did not teach. Why? Because they thought this is a rare question. Yes or no? This is rare question. This will not come again. But next year also the question came. Then they started teaching. Nowadays you can see they are teaching. In the coaching institutes, people are teaching SSA. Now let me tell you what will happen. Okay. See, this concept that we will study now, this is a very simple concept. This is, you will see this. This is a very simple concept. The concept of Phi node. The Phi node concept. So this concept is very standard concept, very simple concept. And in the future exam, this question will come. I can say after some time, okay, after some time, the question will come from this concept. So anyway, let's continue this. So let's study this concept. So remember, this is a future GATE exam question will come from this concept. Okay. So basically this is converting conditional statement and loops into SSA. So far what we have done, can anyone tell me? Can anyone tell me so far what we have done? So far what we have done, can anyone tell me? So far we have converted straight line code into SSA, right? Yes or no? So far you have a straight line code which you have converted to SSA. You have a straight line code. Do you agree with me? Do you agree with me that so far the straight line code you have converted to SSA? This straight line code, okay, very simple straight line code is there, and that we have converted to SSA. Converted to SSA, right? But so far, did we consider conditional statement? Did we consider loop? Did we consider conditional statement? Did we consider loop? Tell me. Now what we are going to do, now we are going to see how to convert conditional statements, you know, if then statements, okay, if then statements, or if you have loop, okay, how to convert these things, how to convert these things to SSA. Okay, so how to convert these things to SSA. And to convert these things to SSA, there is a concept. This conversion is done to convert, okay, to convert to SSA. We use a concept of Phi node. Okay, this Phi node concept we use. This concept is very simple concept. It will become your favorite, don't worry. This is a very interesting concept. So this Phi node concept we use. Okay, let's see what is this concept. So remember, conversion of conditional statements and loops into SSA. And for this, we use this Phi node concept. So let me tell you what to do. Okay, look at this program. Convert this program into SSA. Can you do that? This program you have, convert this program to SSA. We want to convert this program. This program has if-then statements. Yes or no? There is if-then statements. So you can see conditional statements you have. Okay, so we want to convert this program into SSA. Now let's see how to do. First, let me tell you what this program means. So you can easily see in this program, basically what will happen? You will assign some value to X. Okay, here what you are doing? You are assigning some value to X. Some value you are assigning to X. Okay, so this is assignment of X. You are using X here. Here you are using X, right? Agree with me? Here we are not assigning X, we are using X. So please understand, here we are not assigning x. Here we are using x. Okay, we are not assigning x. So this is actually x equal to 40. Basically, is x equal to 40? So remember, this is actually x equal 40. Okay, so very simple. Now you can see here you are assigning, here you are assigning, and then here you are using. Here we use y. Okay, here we assign y. Here also we assign y. Okay, so very simple. Now, actually what will happen? First, you will put some value into x. Then you will check, is x equal to 42? You are checking, is x equal to 42? Yes, if x is equal to 42, means if this is true, then you will execute y equal to 1. This is what you will execute. And if this is false, then you execute y equal to x plus 2. Okay, and after that, at the end, you will execute print y. Yes or no? This is what you are going to do. Now let's convert this into SSA. Okay, now let me convert into SSA. So tell me, do I need to do anything for x? Do I need to do anything for x? No. Yes or no? Because x only assigning once. See, only here x is assigning. Yes or no? Here we are assigning x. Look at this. Here we are assigning x. Only here we are assigning x, so we don't have to worry about x. But there is assignment to y here also. Here we have to care. Okay, so what we have to do? Here we have to take care. So what I can do? I can write y1 here, I can write y2 here. So can I say this is your answer? Tell me. Can I say this is your answer? Just tell me. Just tell me, do you think this is the answer? This is the final answer? That I'm putting y1 here, I'm putting y2 here. Okay, you can see. Now we are using different variables for y1, for y. You can see y1, y2. So can I say this is the answer? No. See, the question is what to put here, which y to put here, yes or no? See, this is correct, this is correct, this is correct, no problem. This is correct, this is correct, no problem. But what to put here? Yes or no? You must be thinking, but what should be put here? This must be what? Please think about it. This must be what? Tell me, can I put y1? Can I put y1 here? Print y1? Will that be correct? Can I put y1? Will that be correct? Can I put y2? Will that be correct? Tell me, can I put y1? Will that be correct? Can I put y2? Will that be correct? What to put here? Is this question clear to everyone? What to put here? See, very simple. If x is equal to 42, then what will actually happen? Just think about it. If x is equal to 42, let's assume if this input value is 42, then actually what will happen? Tell me. If this input value is 42, then actually what will happen? Then this will be executed and you will print y1. Yes or no? Agree with me? Then this will be true and you will print y1. Y1 will be printed. Okay, but notice, if this input is, let's assume 50. Let's assume this input is 50. Then this will happen. Then this will become false. Yes or no? This will become false. Okay, then what will happen? Then y2 will happen here. Is this understood? So tell me, what should I put? I don't know what is the value of x. I don't know what is the value of x. So should I put y1 or y2? If I put y1, will that be correct? Just tell me. If I put y1, will that be correct? If I put y1, will that be correct? Just tell me. I am putting y1 here. Will that be correct? No, that will be wrong. Yes or no? So this also will be wrong. Okay, if I put y2, will that be correct? If I put y2, that also will be wrong. This is also wrong. So what is correct then? Now let me tell you. So in this type of situation, to convert into SSA, we use a concept of phi. We use phi instruction. What we use? We use phi instruction. Okay, let me tell you what we do. In SSA, there is a special instruction. SSA has a special instruction. SSA, this static single assignment form, SSA has a special instruction. Okay, a special instruction when multiple values are coming to a point. Yes or no? When multiple assignments when multiple assignments, or I can say multiple definitions of a variable are coming to a point, when multiple, or I can say when more than one definitions, when more than one definition means assignment, right? Yes or no? Definition means assignment. So remember, SSA has a special instruction when more than one definition reach, when more than one definition of a variable reach at a point, this type of point is called join point. Okay, this type of point where basically multiple definitions are coming, this type of point is called joining point. Is this clear? Okay, is this clear? This type of point, this is your point, right? This is your point. So this type of point is called joining point. Okay, this type of point we call it join point. Anyway, so is this clear? So this is special instruction. What is this special instruction? This is special instruction is Phi instruction. This is special instruction is Phi instruction. Okay, so actually what we do, let me tell you, we have a special instruction. Basically what this Phi instruction will do, this is a function. This Phi instruction will take two variables. See, there is a confusion. We should use y or y because ultimately there is a print y here. See, ultimately there is a print y here. What is the confusion? Tell me. Just tell me what is the confusion. You tell me. You tell me what the confusion. The confusion is this y should be y1 or y2. Agree with me? The confusion. What is the confusion? That you tell me. The confusion is this y should be y1 or y2. So what you do? No problem. Give this to this Phi function. Okay, you are confused. What to use? Y1 or y2? You are confused. You don't know. Should I use y1? Should I use y2? So no problem. This is a magical function. Okay, let's assume this is a magical function. Think about this function as a magical function. This is the magical function. Okay, let's call this magical. This is a magical function. Okay, what is this? This is a magical function. Okay, to this magical function, you give y1, y2 because you are confused. Okay, I am confused. Should I use y1? Should I use y2? Because I want to print the value of y. So should I print the value of y1 or should I print the value of y2? So no problem. Use the Phi function. Is this clear? Because more than one definitions are reaching at a point. More than one definitions are reaching at this point, Yes or no? So use this Phi function. And what you do? This Phi function will either give you y1 or it will give you y2. See, if you come from here, it will give you y1. This Phi function, this is a magical function. Please understand, this is a magical function. So if you come from this side, this Phi function will give you y1. If you come from this side, this Phi function will give you y2. This is a magical function. Okay, so what you do? Basically, you just use y3. Okay, and what you will print? You just print y3. Is this clear? Please tell me. Just print y3. So this is the solution. Is this solution clear to everyone? Did you understand the original problem? See, this was your code. In this code, did you understand the problem? Let me know. Did you understand the original problem? Like what to put here? Should I print y1 or should I print y2? This was the problem or not? I'm asking you some questions. First to tell me, did you understand the original problem? The ambiguity, did you understand? Please tell me. You understood, right? Okay, because here we want to print the value of y. Should I print y1 or should I print y2? So there was a confusion here. Okay, you cannot print y1. If you print y1, that is wrong. If you print y2, that is wrong. Yes or no? Because if you go like this, then you should print y1. If you go like this, then you should print y2. So basically, what value I should print here? That will depend on which branch I am taking. Yes or no? Okay, so which value of y I should print here, that will depend from which side I am going. Okay, from which side I am coming to here, to this point. So what I can do, very simple, just use a Phi function. This special instruction you use. Okay, this is a magical function. This is a magical instruction. This will give you this Phi function. What it will do? If you go by this direction, then this will give you y1. This Phi function will return y1. And if you go by this direction, then this Phi function will return y2. Whatever value this Phi function will return, you put that into some variable y3, and this y3 you put here. Okay, did you understand? Let me know. Please tell me. Please tell me, did you understand this phi function? Let me know. Yes or no? Is this clear? See, very simple point. Let's assume that here some y value you are assigning. See, let me tell you. Here, let's assume some y value you are assigning. Okay. Here also some y value you are assigning. Here also some y value you are assigning. Okay. Now, here also, and here also. Now let's assume that at this point you want to print the value of y. Okay, what you want to do at this point, you want to print the value of y. I want to print the value of y. Okay, now I can come from here also. I can come from here also. I can come from here also. Okay, is this clear? I can come from this side also. Let me call this as. Let me call it even as. Let me call it E2 as. Let me call it E3 as. Okay, is this clear? So I can come. This is just the as name. Okay, what is this even? This is the as name. I am giving you as name given by me. This is just the as name given by me. Okay, for understanding purpose. For understanding purpose, I am giving this name even. Is this clear? Now, what is the confusion? You tell me. Just tell me what is the confusion. Okay, now this is in SSA or not? First, you tell me. First, you tell me, is this in SSA? Is this in SSA? This is not in SSA, right? This is not in SSA because you can see here also you are assigning y, here also you are assigning y, here also you are assigning y. So this is definitely not in SSA. Is this clear? Assigning y, assigning y, assigning y. So this is not in SSA. Now let's convert to SSA. What I will do? I am converting to SSA. Okay, I am converting to SSA. So if I want to convert to SSA, what I will do? Very simple thing I will do. I will call it y1, I will call it y2, I will call it y3. Yes or no? I will call it y3. Okay. So is my work over? Can I say my work is over? Can I say I have created SSA? Did I create SSA? Did I create SSA? No. Now there is a problem. This y should be what? This y should be what? Should this be y1? Should this be y2? Or should this be y3? Did you understand the problem? You understood the problem, right? This y should be what? Y1 or y2 or y3? I don't know. I don't know. If you are going by this age, if you are coming here at this point, okay, at this point, if I am coming from this side, then I should print y1. If I am coming from this age, I should print y2. If I am coming from this age, I should print y3. Yes or no? So the solution, where is the solution? So what to print here? Let's call it join point. Okay, this type of point is called join point. Is this clear? See, this type of point, what this point is called? Tell me what this point is called. This type of point is called what? This is called join point. Join point or merge point. Okay, because many edges, they are basically coming here. Okay, so you can call it join point, merge point, something like this. Okay, so here what you can do in this type of situation, what you can do, basically we don't know, should I put y1 here, y2 here, y3 here? That is the confusion. Okay, so at this point, should I print y1? At this point, should I print y1 or should I print y2 or should I print y3? That is the problem. That is the confusion. Okay, what is the solution? So that is the confusion, right? Yes or no? So the solution is this. The solution is use a magical function. See, I am not calling it magical. I am not calling it magical. Everyone calls it magical. Okay, everyone calls it magical. Harvard University, okay, or Washington University, all of them, they call it magical. So use a magical function, which is a special function in SSA, which is a special function provided by SSA, which is a special node provided by SSA. Provided by SSA. Okay, is this clear? So this is provided by SSA. So use a magical function. This phi function you use, okay, phi y1, y2, y3. This function you use. That's it. That's it. That's it. This function will give you the correct value. Okay, because this is a magical function, so this will give you the correct value. If you come from this side, it will give you y1. If you come from this side, it will give you y2. If you come from this side, it will return y3. Okay, is this clear? So just use this magical function, and this, let's assume this magical function will give you the correct value. Okay, y1, y2, y3. And you just put this into some other variable y4, and then you print y4. Is this clear? And then you print y4. So very simple point. What you basically need to do, let me tell you. Basically, you just need to do this. Instead of printing y, what you can do this. See what you can do. You can do this. First, you can use a phi function. Okay, this phi function, it will be like this, that if you come from this edge, then it will give you y1. Is this clear? Okay, are you getting my point? That if you come from this edge, it will give you y1. If you come from this edge, it will give you y2. Understood or not? Okay. And if you come by this edge, it will give you y3. Okay. The value you can store into y4. And finally, just print y4. Just print y4. Okay. Is this clear? So that's it. I hope you understood. The same thing you can write like this. The same thing you can simply write like this, that this phi function, just give y1, y2, y3 to this phi function, and this will give you correct value, and then you can just print this y4. Understood? So did you understand this magical function? This magical function, did you understand? Please tell me. So there is a magical function here. Basically, you are confused what to do. Should I print? What to do? What to print here? So very simple. Just use this magical function. Okay. If you are coming from this side, then you use y1. If you're coming from this side, then you use y2. Okay. So remember, you can directly put it y1, y2. No problem. This is also correct. Means you can directly say y1, y2. That is also correct. y1, y2. You can directly say y1, y2. That is also correct. Okay. So this is the point. Understood? Is this clear to everyone? Now, you might be thinking how we can use a magical function, how to execute this, how to execute, yes or no? During the execution, how we will know what is this? Yes or no? Are you thinking? Please tell me. Are you thinking how we can use a magical function in the program? A magical function, how we can use in a program, how to execute this instruction, how to convert this instruction, this phi instruction, how to convert this instruction into assembly language code, into the machine code, how to convert this. Are you thinking? So let me tell you, this SSA program we never run. Okay, let me tell you. See, SSA program is never run. SSA program is intermediate representation. Please understand. SSA program is just an intermediate representation. We are never going to run it. It's just an intermediate representation. Is this clear? We are never going to run it. We are never going to run it. Is this clear? Please tell me. Is this point clear? That we are never going to run it. So don't worry about it. See, you might be thinking, sir, how to run it? If we run, then how we will know? So no problem. We are never going to run it. This is just an intermediate representation. We are never going to run it. Is this clear? Please tell me. So actually, let me tell you what we do. This SSA we use only for optimization. SSA is used only for optimization. Only for optimization. Means what we do? We convert to SSA, do some optimization, and then we convert back to 3 address code. Okay. See, very simple point. Basically, what we do, this 3 address code we convert to SSA. Please notice this 3 address code or control flow graph, either 3 address code or control flow graph. Okay. This we convert to SSA. This we convert to SSA for optimization. What you do? For optimization purpose, please understand, for optimization purpose, we convert to SSA. Okay. We do some optimization. Okay. On this SSA, we do some optimization. And then let me tell you, then we convert again to 3 address code or control flow graph. Did you understand? So we are never going to run it. This SSA, we are never going to run it. I hope you understood this. Actually, why SSA? See, SSA makes optimization easy, makes certain optimizations easy. Certain optimizations easy. Can you think about it? Why? Certain optimizations very easy. Anyone? This is very, very intuitive. SSA makes certain optimizations very easy. Very easy. Okay, very easy. Okay, let me give you the analogy. You tell me, in this real world, do two different people have different names? Tell me. In the real world, you tell me. In the real world, different people, do they have different names? Not necessarily. Yes or no? See, SSA simply means don't give same name. Yes or no? To different assignment. Okay, see what this SSA says. SSA says that this SSA is saying that don't give same name to different people. Yes or no? Don't give same name to different assignment. To different assignment. To different assignments. Yes or no? This is what SSA says. Now you tell me, just consider this situation analogy. You consider in the real world, I am also Deepak. Maybe your name is also Deepak. Maybe there are many Deepak. Yes or no? So now just think about it. If there is a rule that two different people will have different names, if there is a rule, okay, two different people have different names, then many things will become very easy. Do you agree with me? Do you agree with me that many things will become very easy? If there is a rule that two different people will have different names, means if I am Deepak, there is no other Deepak. Okay. Is this clear? Please tell me. Are you getting my point? So if there is a rule that in this world, two different people will have different names, then many things will become very easy. Agree with me? Okay. Yes or no? So that is the same idea. Remember, in the SSA, we are giving different names to different assignments. Yes or no? Basically, this SSA, what it does, it gives different names. It gives different names. Different names to different assignments. Agree? Yes or no? Is this clear? So to different assignments. So because of that, many optimizations there will become very easy. Okay, because of that, what will happen? Many, I can say certain optimizations, they will become very easy. So SSA is only used for optimization. SSA, this is useful for certain optimizations. Okay, some kind of optimizations you can easily do on SSA. Is this clear? Please tell me. So very simple. So we are never going to run it. Is this clear or not? Please tell me. So that is the reason. Again, I'm telling you, you have a 3-address code or you have a control flow graph. This you will convert into SSA. You will do some optimization on this SSA. You will perform certain optimizations you will do. Okay, some optimizations you will do. After doing these optimizations, what you will do? You will convert again to 3-address code or control flow graph. Is this clear? Please tell me. Let me. So remember, for optimization purpose, we do this. For optimization purpose, we do this. Nothing else. Once our certain optimizations are over, then we will I can say convert, I can say into normal 3-address code or control flow graph. So we are never going to run the this SSA. So don't worry about Phi function. Is this point clear now? That is the reason we can use this magical function because we are not running it. This SSA we don't convert into machine code. We are not going to convert SSA to machine code. We are not going to run SSA code. This is just only used for optimization. Do the optimization and then you convert again to 3-address code. Is this point clear? Please tell me. Let me know. So remember, we don't care about the Phi function. So remember, there is a magic function. You can see this is IIT Kanpur slide. IIT Kanpur slide. You can see there is a magic function. This Phi function. This is Phi used for selection. Agree or not? We use this phi for selection. Yes or no? If there are multiple things are coming, okay, at a point, if multiple things are coming, like let's assume y1 is coming, y2 is coming, y3 is coming, then we use phi function for selection. Okay, means which to select, y1, y2 or y3, which of them to select, and you put that into y4. So very simple, this is used for selection. Not every join node needs a phi function. Basically, you need this phi function only if multiple definitions are reaching that node. Yes or no? I will give you the example, don't worry. If multiple definitions are reaching at this node, then you use phi function. Yes or no? If only single definition is coming from every, like for example, just think about it, tell me, if from this side, let's assume x is coming and y1 is coming. From this side, let's assume x is coming and y1 y2 is coming. And from this side, x is coming and y3 is coming. Then tell me, you will use phi function for x or not? Will you use phi function for x? Will you use phi function for x? No, there is no need. Yes or no? Because from this side also x is coming, from this side also x is coming, from this side also x is coming. Yes or no? Is this clear? So there is no need for x. Okay, so you will use phi function for y1, y2, y3. For these, you will use the phi function. There is no need of no phi function for x. Needed for x. Okay, is this clear? So I hope you understood this. So let's move on. Now, but what is this phi? So let me tell you, this is just a conceptual entity. This is IIT Kanpur slide. You can see this is just a conceptual entity. Is this clear? Read this word. This is just a conceptual entity, nothing else. We are never going to convert into machine code. Is this clear? Okay, we will never convert into machine code. This is just a conceptual entity. Okay, I hope you understood. Now let's move on. So remember, like this is a very beautiful line you can see here. Okay, see, how do we choose which value of xi to use? We don't really care. Okay, see, you might be thinking how this phi function will decide which value to return. Yes or no? Are you thinking? Is there anyone here who is thinking, sir, how phi function will decide which x value to return? Which x value to return? So remember, we don't care. Okay, is this clear? We do not care. So this is a very beautiful line you can see. Okay, so just notice this. Now let's move on. Now let's see this example. This is a Ullmann question, a beautiful question. Let's solve it. Convert the following program with conditional statement into SSA. Okay, this code is given to you in the Ullmann book. Now what we need to do? First of all, you tell me, is this in SSA? Right now you tell me, is this in SSA? Look at this and tell me, is this in SSA? Right now, do we have this in SSA? No, this is not in SSA, right? Yes or no? So this is not in SSA. Okay, because you can see you are assigning more than once. Okay, so this is not in SSA. Right now, this program text, this is your program text, and this program text is not in SSA. So how to convert? We need to convert into SSA. Anyone want to help? This is your code. Your code is something like this. If flag something, then if this is true, then x will be -1. Else x will be 1. Okay. Whatever you do here, basically you will do x into a. Okay. Let's convert this to SSA. We are going to convert this to SSA. First, just create the graph. Okay, that is very easy. First you write a graph for this. Okay, the best way I'm telling you, first you create a graph for this. So what the graph will look like? See, the graph will look like this. If flag, the graph will look like this. If this is true, if this flag is true, then what will execute? Please tell me. if this is true, then what will execute? And if this is false, then what will execute? If flag is true, then what will execute? Then x equal to -1 will execute. If flag is false, then who will execute? Then x equal to 1 will execute. Yes or no? Is this clear? Please tell me. Okay, if this is true, then you will execute this. If this is false, you will execute this. So very simple. And whatever you do, at the end, you need to execute this one. Okay, at the end, you need to execute y equal to x multiplied by a. This is what you need to execute at the end. Clear? So from here. Okay. Now let's convert. Now what we will do? We will convert. I hope you understood. So remember, this is your code. If there is flag, okay, this is what you have. Now, if on the true branch, what will happen? On the false branch, what will happen? True branch, false branch. In the true branch, basically x equal to -1. You will put x equal to -1 in the true branch. And in the false branch, you will put x equal to 1. And at the end, what you are going to do? At the end, you are going to do this. Y equal to x into a. Okay. So this is the given code. Let's convert into SSA. First of all, right now, this is not in SSA, right? Yes or no? Okay. Right now, you can notice this is not in SSA. Not in SSA. Now let's convert into SSA. So what the first thing you will do? See, for SSA, this is assignment to x. This is assignment to x. First, you will do this x1, x2, right? Yes or no? This is very simple. Do you agree with me? Yes or no? In the SSA, I want to convert to SSA. So you can see this is assignment to x. This is assignment to x. So first I will do this. This I will write x1. This is I will write x2. Is my work over? Please tell me. Can I say my work is over? Can I say my work is over? No. My work is not over, because what this x should be? See, what this x should be? Should this be x1 or should this be x2? Yes or no? This should be x1 or x2. Is this clear? This x, this should be x1 or x2. So what to do? See, if you are coming by this side, then this should be x1. If you are coming by this side, this should be x2. Yes or no? So what to do? Should I put x1? Should I put x2? So here phi function will help you. Yes or no? So here who will help you? Very simple. A magical function is there. A magical instruction is there. That phi function is going to help you. Okay, so here a phi function is going to help you. So what you can do? You can write a phi function. Okay, the phi function will help you. x1, x2. Just basically this phi function will return the correct value. Remember, this is a magical function. Okay, this has magic powers. Is this clear? Remember, this is a magical function. And because this is a magical function, so this will return the correct value. Means if this flag is true, means if you are coming by this side, then remember phi function will return the value x1. If this flag is false, then basically you are coming from this side, then this phi function will return x2. Remember, this is a magical function. It will return the correct value. Okay, phi function will return the correct value. So this you can store into some variable x3. And finally, you can just use this x3 here. x3 multiplied by a. Okay. Is this clear? Please tell me. So now this is your SSA. Now this is the SSA. Are you finding this interesting or not? Please tell me. See, many beautiful questions can be created on this phi function. On this phi function, many beautiful questions can be created. And I promise you one thing. In future GATE exam, this phi function will come. One day this question will definitely come. And only the Go classes students will be able to solve it. Two easy marks. Only Go classes students will get. Okay. So, and after that, every coaching institute will start teaching this concept. Okay. So this happens. Anyway, now let's see this. Is this clear? Please tell me. Now let me tell you. See, either you can write like this. Okay. Or there is another way of writing. Basically, you can write like this. See, if you are coming from this side, okay, let's call it, okay, let me call it A, let me call it B. Means if you are coming from A side, then x1, and if you are coming from B side, then x2. Is this clear? Means if you are coming from A side, then x1 return x1. If you are coming from B side, return x2. So you put in x3 and then you use x3. Anyway, this is just a small, either you can write like this or you can write like this. Both are fine. Both are fine. Okay. Both are fine. Okay. So this was in the diagram. Now in the program text, how to do? See, in the diagram we have done, but in the program text, how to do? This program text, how to convert to SSA? So let's convert to SSA. Now you already know how to do that. This program text, you can easily convert like this. If flag x1 equal to -1, else x2 equal to 1, then where the phi function you will put? After this or before this? Please tell me. Where the phi function you will put? Please tell me. Where are you going to put the phi function? Before this or after this? Before this, right? Yes or no? So before this statement, you are going to put the phi function, phi x1, x2 in x3, and this x3 you use here. Okay. So this is the idea. I hope you understood. This is the idea. This is your answer. Is this clear? Tell me. Okay. So very simple concept, phi function. Very, very, very simple concept. You can see. Okay. So this is the phi function concept. Now let's solve some more questions. So right now tell me, is this in SSA or not? Look at this program text. Is this in SSA? This is your program text. Is this in SSA? Okay. See, this is the graphical representation. Okay, but you tell me, this program text, this is not in SSA, right? Okay, this is right now not in SSA. Not in SSA. So convert into SSA. Why this is not in SSA? Why this is not in SSA? You can see. See, you can see you are assigning I here also, here also. Okay, notice you are assigning J here also, here also. So that is the reason this is not in SSA. Is this clear? So convert to SSA. What you do? Convert into SSA. Can you do that? Now this is cakewalk for you. You are expert now. Okay, now you are expert. So let's convert to SSA. See what is happening. First you are assigning I, assigning J. Okay, you are assigning some value to I, you are assigning some value to J. Then what you are doing? Then you are checking, is I less than 20? If I is less than 20, if this is true, then you will execute I equal to I plus J. If this is false, then you will execute J equal to J plus 2. And finally, you will print I comma J. Okay. Is this clear? So we need to convert this into SSA. You tell me very simple point. So let's convert to SSA. Okay, let me try. First, you can see this is assignment of I, this is assignment of I, this is assignment of J, this is assignment of J. So what I should do? What is my starting point? Tell me, what should be my starting point? My starting point should be, I can make it I1, I can make it I2. Yes or no? Agree or not? I can make it J1, I can make it J2. Yes or no? Okay, is this clear? Please tell me. So far everything is clear. See, I can make it I1, I can make it I2, I can make it J1, I can make it J2. So far everything is fine. You tell me, what is this J? Is it guaranteed to be J1? Can you guarantee this will be J1? Can you guarantee? Can you give me a guarantee that this will definitely be J1? Please tell me. Can you guarantee that this will definitely be J1? Yes. This will definitely be J1, right? Okay. Because see, if this happens, then you will always have J1 here. Yes or no? And can you guarantee this will be J1? Can you guarantee this will be J1? Yes, this also will be J1. There is no problem. Okay, this also will always be J1. Correct or not? This also will be J1. So there is no problem. This always will be J1, right? Yes or no? Okay, see, whatever happens, whatever happens, this always will be J1. And what about this? This always will be I1. Okay, so everything is fine so far. What should I print? Should I print, okay, here you are I2, here J2. So should I print I2, J2? So can I say that will be correct answer if I do I2, J2? If I do I2, J2, means this I2 is coming from here, J2 is coming from here. So if I print I2, J2, can I say this is correct answer? If I do I2, J2, can I say that will be correct answer? Where is the problem? This is not correct answer. This is not correct. Where is the problem? You tell me the problem. You tell me, find problem. Can you tell me the problem? Can you find the problem? Tell me. Anyone? Where is the problem? Let me know. In this entire code, where is the problem? This is not correct, but you find the problem. Can you find the problem? Where do we have the problem? Is there any problem here? I'm asking you, is there any problem here? No, there is no problem here. Is there any problem here? No. See, this will always be J1. This will always be J1. This will always be I1. So there is no problem. Yes or no? And here you are using I. Here you are not assigning I, you are using I. So where is the problem? Let me tell you, here is the problem. Okay, let me tell you, here is the problem. Why this is the problem? Why this is the problem? See, notice. If this is true, just assume if this is true, then should I print I1 or I2? Notice one thing. Okay, here there is a problem. Why there is a problem? Notice. Okay, there is a problem. Why there is a problem? Let me tell you. The problem is like this. If this is true, the problem is like this. If I is less than 20, means if this is true, means if this is true. Is this clear? If is true. Okay, means if is true. If is true, then tell me what should I print? Just tell me what should I print? Please tell me. If is true, means if this is true, then what should I print? Then I should print I2 J1. Very good. Then I should print I2 J1. Agree with me? And if is false, if is false, then tell me what should I print? Then what should I print? Means if I go by this direction, then I should print I1 J2. Okay, so did you find the problem? I am directly writing I2. That is wrong. Yes or no? I am directly writing I2. That is wrong. Understood the problem or not? Please tell me. Did you understand the problem? Now what the solution? You understood the problem, so tell me the solution now. So what should I print here? So what should I print here? You understood the problem, but what should I print here? This should be I1 or I2. What should be this? Similarly, this should be J1 or J2. What should be this? So tell me the solution. What should I do? Yes, very simple. Just use the Phi function, right? Yes or no? Just use the Phi function. So very simple, Phi function. Use the Phi function. If you are coming from this side, okay, just use the Phi function. If you are coming from this side, then what should be printed? Just put I3. Tell me, if you are coming from this side, what should I print? Tell me, if you are coming from this side, what should I print? I should print I2. Okay, and if you are coming from this side, I should print I1. Similarly, for J, you tell me, for J, if I coming from this side, then what I will do? Then I will print J1. And if I coming from this side, then I will put J2. Okay, and just create J3. So finally, you can say I3, J3. This solution understood? Is this clear? Please tell me. See, very simple solution, that if you coming from this side, then I2 should be printed. If you coming from this side, I1 should be printed. So one Phi function for I variable and one Phi function for J variable. Is this clear? one phi function for I variable, one phi function for j variable. Please tell me understood or not. So I can say this is a one phi function for one phi function for I and one for j. Okay, so is this clear? Please tell me. So if you go by this side, then j1 should be printed. If you go by this side, j2 should be printed. Okay, and finally you can print I3 j3. Is this clear? Please tell me understood or not. Let me know. Let me know understood or not. Please tell me. Is this point clear or not? Please tell me. So like this you can create. This you can convert into SSA. This code you can convert into SSA. Basically, here you need to put phi function. Okay. What you need to do? You need to make it I1, you need to make it J1, you need to make it I2, you need to make it J2. And then you can easily see here you need to put phi function. See, here you need to put I1 and here you need to put I2. Then you can see here J1, here J2. And then you can see that phi functions you need to put. Okay, you need to put phi functions you need to put. So these phi functions you need to put. Finally, so you can see, finally, you can print J3, I3. Okay, is this clear? Please tell me. Now, did you notice one thing? Is there anyone here who noticed one thing that I am writing I2, I1, J1, J2? I am writing I2, I1, J1, J2. Can I change the order? Like, can I write I1, I2, J1, J2? Can I write that? See, did you understand? Notice what this simple point you notice. Okay, notice one thing. Here you want to print. Okay, remember here you want to print I, j. Okay, you want to print. See, you want to print I, j. You want to print. Okay, this is what you want to print. I, j. Now, from this direction, who is coming? From this direction, who is coming? From this direction, I2 is coming, J1 is coming. Correct? I2 is coming, J1 is coming. From this direction, who is coming? J2 is coming, I1 is coming. Okay, is this clear? From this direction, this is coming, this is coming. Is this clear or not? Okay, let's call this direction. Let's call this direction E1. Let's call this direction E2, or you don't have to write. So basically like that. See, okay, maybe let's call this point. Okay, let me call this point A. Let me call this point B. Okay, these are just points. This is just a point name given by me. Okay, so these are just point names. Okay, this is just a point name. Okay, now see one thing. Notice one thing. Can I write like this? I'm using the phi function. Okay, I need to put the phi function that you already know. So let me put the phi function now. I'm putting the phi function. So you tell me, can I put the phi function like this? That okay, I1, I2, I1, I2, I1, I2, and J1, J2, and J1, J2. Okay, will this be correct or not? And then you print I3, J3. Okay, so tell me, will this be correct or not? Why this is not correct? Tell me why this is not correct. See, this is not correct. You are putting I1, I2, J1, J2. This is not correct. Okay, this is not correct. Is this clear? This is not correct. Why this is not correct? Because very simple thing. See, this is not correct. Very simple thing. Okay, basically what to do here. Okay, so this is not correct. Now let me tell you why this is not correct. Because yes, order matters. Okay, order will matter. Because order will matter. Okay, order will matter. So you have to use the same convention. The order will matter. For example, if you are writing like this, see. If you are writing this age here, means first if you are writing this age, means on this age what is coming. Okay, if first you are writing this age, then every time you should write this age. Like for example, first you are writing this age, means I2, I1. Okay, on this age I2 and on this age I1. then the same convention you should follow for j. Okay, the same convention you should follow for j, j1, j2. Is this clear? Please tell me. Please tell me simple point. This is not a complicated point. Just tell me simple point. Did you understand? So the same convention you should follow means if first you are writing this age, okay, this age you are writing first, then every time you should write this age first. Is this clear? Okay, so finally you can print I3 J3. This you can print. This is correct. Okay, this is correct. Now remember one more thing. See the benefit, let me tell you. Now if you use this notation, then there is no problem, right? See, if I use this notation that from B side if you are coming, then put I1. Okay, and from A side you put I2. If I use this convention, then there is no problem, right? Do you agree with me? Do you agree with me that if I say that from B side if you are coming, then return I1. If you are coming from B side, return I1. If you are coming from A side, return I2. Yes or no? If you are coming from A side, return J1. If you are coming from B side, return J2. This is also fine. Is this clear? So basically, if you are using this convention, if you are writing basically from where you are coming, yes or no? From which age you are coming, from which age you are coming, if you are writing that also, then there is no problem. Okay, then there is no problem of convention. Then we do not have any problem of order. Then we do not have any problem of order. But if you are directly writing I1, I2, then you should follow the order. Means if first you are writing this age, then every time you should write this age. Okay, is this clear? So this matters. I hope you understood. I hope this point is clear. So remember, ordering of phi arguments according to the age ordering is important. Okay, so this is a small note. This is not a complicated point. This is a small note. Okay, so I hope you understood. So let's move on. So we have seen everything. You can just notice these are the properties of phi function. You can have multiple phi function, no problem. For multiple variables, you can put phi function, no problem. Okay, for multiple variables, you can put multiple phi functions. Okay, these are placed only at the entry of the join node. Okay, we just put them at the entry of the join node, nothing else. Okay, so and remember, for every variable we don't have to create the phi node. We do not have to create phi node for every variable. For example, can you convert this into SSA? Can you convert this into SSA? First of all, you tell me right now, is this in SSA? Right now, is this in SSA? This is not in SSA, right? Okay, why this is not in SSA? Right now, this is not in SSA. Tell me why. Because here you are assigning Y. Here also you are assigning Y. Okay, so this is not in SSA. Now let's convert this to SSA. Okay, now I am converting this to SSA. So tell me what to do to convert to SSA. Now I am converting to SSA. Okay, so tell me what the first thing I will do. Very simple. I will make it Y1. I will make it Y2. Okay, yes or no? Is this clear? Now, where is the problem? The problem is here. See, the problem is here. This should be Y1 or Y2. This should be Y1 or Y2. That is the problem. See, this is fixed, right? If I make it X1, can I guarantee this will always be X1? Can I guarantee this will always be X1? Please tell me. If I say this is X1, can you guarantee that this will always be X1? Can you guarantee, like, if you go like this, then also it is X1. If you go like this, then also it is X1. So this will always be X1, right? Is this clear? This will always be X1. This will always be X1. This also will be X1, right? Yes or no? Is this clear? Please tell me. So remember, for X, you don't have to write a phi node. There is no need to write phi node for X. Is this clear? We do not have to create phi node for X because there is no ambiguity with X. We have no ambiguity with X. So there is no need to put the phi node for X. Okay, we don't have to create phi node for X. So this phi node you can create only for Y. Y1, Y2, put some Y3, and then finally you can see in this Z you can put Y3 plus X1. Okay, so you can notice, so for x, no phi node required, no phi node needed. Is this clear? Please tell me, understood? We only need phi node for y. Only for y we need phi node. We don't need for x. Okay, is this clear? No problem, you can keep it x. Okay, Satyam is asking why x1? No problem, you can keep it x. Okay, don't worry, don't worry, don't worry. This, okay, this is not a problem. Sorry. This will be x. Sorry for that. Because see, if you make it x1 here, then it will be x1. See, like if you make it x1, then it will be x1. Okay, but you can keep it x, no problem. Is this clear, Satyam? Means I am saying that if you make x1 everywhere, then it will be x1. Basically, the same x is coming. Okay, by this path or by this path, same x is coming. Okay, so this is the point. So you can see, this is the point given to you. Not every join node needs phi operator for every variable. Basically, for every variable, you don't need a phi node. Like here, for x, we don't need a phi node. For x, there is no phi node required. Okay, no phi node is required. Only for y, we need a phi node. Okay, so this is how you can convert. Only for y, we need a phi node. We don't need phi node for x. So I hope you understood this. Remember, phi node is a conceptual entity. This is a magical function, and this is a conceptual entity. This is just a conceptual entity. And how this will decide, this phi function, how it will decide which variable, which value to return, we don't care. Okay, we don't care. One last example I want to take, that is regarding loops. How to convert loop into SSA. So far what we have seen now you tell me, so far what we have seen. So far we have seen a straight line code, how to convert into SSA. If you have a straight line code, how to convert into SSA, we have seen, yes or no? If you have a straight line code, how to convert that into SSA, that we have seen. This we have seen. Also what we have seen, tell me. Also what we have seen, let me know. Also what we have seen. We have seen if then statement. If then statement. How to convert them to SSA. This also we have seen. You have become expert. Yes or no? Here we use phi nodes. Okay. Yes or no? So now what we are going to do, now we will see how to convert loops into SSA. The same phi node we are going to use. So I am giving you one example. Can you solve it? Can you solve it? Can you convert this into SSA? First, you tell me right now, is this in SSA? Is this in SSA right now? Tell me. Is this in SSA right now? Right now, is this in SSA? The answer is no. This is not in SSA, right? Because look at the program text. Look at the program text. Look at the program text. In the program text, this variable A you are assigning multiple times. This variable B you are assigning multiple times. Yes or no? So this is not in SSA. Let's convert to SSA. Let's convert to SSA. Can you do it? Let's convert to SSA. Can you do it? So very simple thing. First, let me write it A1. Let me write it B1. Yes or no? Let me start. Let me write it A1, B1. So this assignment I will write B2, A2. Agree with me? So far, do you agree with me? Okay, are you with me so far? See, very simple. I want to convert into SSA. So this is A1, B1. These assignments are A1, B1. So these assignments must be different. To the same variable, I cannot assign more than once. Yes or no? To the same variable, you cannot assign more than once. So I'm writing it A1, B1. I'm writing it A2, B2. So far, everything is fine. So can I stop here? So can I stop here? Please tell me. Can I simply stop here? Think about it. Can I stop here? No, I cannot stop. So where is the problem? Where is the problem? There is a problem. There is a problem. Where is the problem? See, there is a problem. Just tell me which B is this. Just tell me which B is this. See, notice one thing. See, notice one thing. See, if you are coming by this side, let me call it as E1. Let me call it as E1. If you are coming by E1 as, okay, if you are coming through E1 as, then this value should be what? Tell me. If you are coming by E1 side, by E1 as if you are coming by E1 as, then this B value should be what? This should be B1. Yes or no? But if I'm coming by E2 as, if I'm coming by E2, there is a E2 as, this is the E2 as. If I'm coming by E2 as, then what should happen? If I'm coming by E2 as, see, this is the E2 as, means I'm coming like this. Okay, I am coming like this. So tell me, now tell me, if I'm coming by E2 as, then this B value should be B2 or not? Understood? Did you understand my problem? This problem, did you understand? See, very simple point. If you are coming by E1 as, then this B should be B1. And if you are coming like this by E2 as, okay, this is your E2 as. I am calling it E2 as. Okay, if you are coming by E2 as, then if you are coming like this, then this B value should be actually B2. Yes or no? Because you are going like this. You are going like this. So this B value should be B2. Understood? Okay, what about this A? What about this A? What about this A? Tell me, what about this A? If you are coming by E1 as, what should be this value? If I am coming by E1 as, then this A should be A1. And if I am coming by E2 as, if I am coming by E2 as, then this value should be A2. Agree? Agree or not? What about this N? Is there any problem with this? Is there any problem with N? Is there any problem with N? With N, do we have any problem? There is no problem, right? Okay, this always will be N. Here there is no problem. This always will be N. For example, if you write it N1, then this always will be N1. Yes or no? If you write it N1, then it will always be N1. Is this clear? So there is no problem with N. So for how many variables we will create phi node? This is my question. For how many variables we will create phi node? How many phi nodes we need? How many phi nodes needed? So the answer will be 2. Answer will be 2. For which variable? For which variables? For variables A, B. Yes or no? For variables A, B. Agree? Do you agree with me? So we need 2 phi nodes. Okay, very simple. We need 2 phi nodes. We need. Okay, if I call it N1, then this will be simply N1. We need only 2 phi nodes. So very simple. I will create 1 phi node for variable A. 1 phi node I am creating for variable A. I will put in A3. Okay, I am putting. So A1, A2. Is this clear? Please tell me. Very simple, right? Now this is a cakewalk for you. You are expert now. B1, B2. Okay, is this clear? Finally, this should be B3. Finally, this should be A3. And this is your SSA. Now this is your SSA. Are you feeling confident or not? Please tell me. So many examples I have taken. Every simple point I told you. Everything I've told you. Everything. Okay. In the next 10 year, 20 year, whatever gate question will come in future or in past, every question you can solve. Every gate question from the past, from the future, you can solve now. From SSA, from static single assignment. This is over. Everything we have seen. Please tell me, did you understand? Please give me your feedback. Please give me your review. Are you feeling confident in SSA? Whatever question comes in the gate exam, from this Phi function, for conditional instructions, okay, for conditional statement, for loop, for straight line code, whatever they give you in the exam, what they can give you in the gate exam, either they can give you if else statement, or they can give you some loop, they can give you, or they can give you straight line code, they can give you. Basically, these things they will give you, yes or no. Whatever they give you in the GATE exam, can you solve? Please tell me, are you confident or not? Very good, very good. Okay. So like this, you can convert into SSA. Like this you can do. Is this clear? So very simple. So like this you can do. Okay. Let's solve this question. Tell me the answer for this question. Let's quickly solve it. Consider the following code segment. This code segment is given to you. The minimum number of total variables required to convert the code segment into static single assignment. So right now, is this in SSA? No, this is not in SSA, because you can see this variable you are assigning 2 times. This variable also you are assigning multiple times. So let's convert into SSA. What you will get? You will get something like A1 equal to B plus C. Then you can say D1 equal to B into E. Then this you can write A2 equal to this. This will be D1, right? Because this is what you are using here. So this will be D1 plus F. And then finally, this D2 equal to this A you will use. Okay. This A you are going to use. So this will be A2 divided by G. So total, how many variables are there? Tell me. A1, A2, D1, D2. Then B, C, E, F, G. So total 9 variables are there. Yes or no? Total are there 9 variables. And how many temporary variables? Okay, see, total variables are 9. Okay. So anyway, in this question, they will ask you only this one. Okay. In this type of question, they will ask you only total variables. They will ask you. Is this clear? In this type of question, they will only ask you total variables. Okay. What is the reason? See, the reason is like this, because whether to consider, for example, you don't have to change it. Yes or no? See, what you do, you can just simply keep it A. You can make it A1. Are you getting my point? So they will not ask you temporary variables in this type of question. In this type of question, they will ask you only total variables. In some poor test series, they can ask you, in this type of question, they can ask you temporary variables. In some poor test series. Okay. In a very poor test series, this type of question they can ask you. But remember, in this type of question, they will not ask you temporary variables. They will simply ask you how many total variables are there, because there is no need to rename it. You can keep it A. Yes or no? You can keep it A. You can make it A1. Similarly, you can keep it D. You can make it D2. Okay, so something like that. I hope you understood. Okay, so very simple. For this question, the answer will be 9. Let's solve this question. This is a beautiful question regarding SSA. Do you really understand SSA? Tell me. Do you really understand SSA? Tell me the answer for this question. Which of the following statements regarding SSA form, static single assignment form of intermediate representation, is false? The statement is asking which is false. So tell me the first one. If a program is in SSA, then use of a variable is reached by exactly one definition of that variable. Is this true or not? Use of a variable is reached by exactly one definition of that variable. Is that correct or not? Let me know. If your program is in SSA form, then use of a variable, when you are using a variable, that will be reached by exactly one definition of that variable. Yes, this statement is true. Yes or no? Yes or no? This statement is true, because remember, for example, let's assume here you are assigning y equal to y1, here y equal to y2, and let's assume here you are printing y. Okay, here you are printing y, right? Yes or no? So this is the use. See, this is the use of y. This is the use of y. And these are the definitions of y. Yes or no? These are the this is the definition of y. Definition means assignment. This is the definition of y. Similarly, this is the definition of y. Definition of y. See, right now this is not in SSA. So if the code is not in SSA right now, this is not in SSA. Because this is not in SSA, so you can notice this use, okay, this use is, okay, this definition also reaching this use, and this definition also reaching this use, yes or no? So if your program is not in SSA, if your program is not in SSA, then this use of variable y you can reach by multiple definitions. Agree with me? Please tell me. This variable, this use of variable y, you can reach by multiple definitions. You can reach by this definition also. You can reach by this definition also. But once you convert into SSA, once you convert into SSA, now this is a variable y1, this is a variable y2. Now they are different variables. Yes or no? Agree? Now they are different variables. Now you tell me. Now because they are different variables, so use of any variable will reach from only one definition. Yes or no? Agree with me? Please tell me. Is this clear? Okay, now you can notice the use of any variable, print y3. So you can notice this is the use. This is the use of y. Correct. This is the use of y. And can you notice this is only reaching from one definition? Yes or no? This is the definition. From only one definition, this use will reach. Please tell me, did you understand this? Let me know. Is this point clear? Anyone? Anyone has any doubt in this? Only by this definition. So this use of variable y, this is only reaching from this definition. Okay. See, very simple point. In SSA, what happens? You know that in the program text, if this is your program text, then in this program text, what will happen? There is only one assignment for any variable that you already know. This is your program text. And in this program text, you already know that for any variable, there is only one assignment. There is only one assignment. This is the only assignment for y. This is the only definition of y. Okay, this is the only definition of y. If this is the only definition of y, then if you are using this y anytime, then that will only reach from this definition or not? Can you reach from other definition? Please tell me. Can you reach from other definition? Can you reach from other definition? No, you cannot reach. Yes or no? So you can notice any use of y will only reach from unique definition of y. Okay, is this clear? So you can notice any use of y will reach from unique definition of y. Unique definition of y. I hope you understood, because there is only one definition of y. There is no other definition of y. There is only one definition of y. There is no other definition of y. So this statement A is actually true. Okay, if your program is in SSA form, then use of a variable is reached by unique definition of that variable. So this statement is true. What about option B? What about option B? What about option B? Flow of control in SSA remains same as flow of control in non-SSA. Yeah, that is also true. Flow of control is not changing. Yes or no? Flow of control is not changing. You are just renaming the variables. Flow of control is not changing. You are just renaming the variables. What about C? Since every variable has exactly one definition in the program text, so there are no loops in SSA. This we have seen, this is false. Loops are fine. You can have loops in SSA. Because remember, this is static single assignment. This is static single assignment, not dynamic single assignment. I told you in the beginning of the lecture. In the starting of the lecture, I told you that this is static single assignment, not dynamic single assignment. So option C, that is false. What about D? What about D? Some compiler optimizations, they perform better on SSA forms. Yeah, that is true. SSA we use for some compiler optimizations. There are some compiler optimizations which are very easy to do on SSA form. If you have SSA form, then these compiler optimizations are very easy to do. So the only false statement is option C. Yes or no? So for this question, the answer will be option C. Is this understood? Please tell me. This is a nice, beautiful question. Okay, I hope you understood. So we have seen every point. You can see this is the summary of SSA. In SSA, what we do, let me tell you the summary. A program is in SSA form if each use of a variable, every use of a variable, notice every use of a variable is reached by exactly one definition. This we have already seen. Flow of control remains same. Okay, as in non-SSA form. There is a special merge operator, phi. This we use for selection of values in the join nodes. Yes or no? Not every join node needs phi operator for every variable. Yes or no? Only for some variables we create phi node. Those variables which basically those variables for which multiple definitions, more than one definition is reaching to a certain point. For those variables we create phi node. Yes or no? We create phi node only for those variables for which multiple definitions, more than one definitions are reaching to a certain point, to the join node. So for these we create the phi node. Okay, yes or no? So if same definition is reaching, then for these variables there is no need to create a phi node. Yes or no? If a same definition is reaching from all path, from here also, from here also, from here also, from all the path, if same definition is reaching, then there is no need to create phi operator. So all these points we have seen. Let's see this final question. Tell me the answer for this question. Consider the expression. This expression is given to you. A plus minus B. See, this is unary operator. A plus minus B into C plus D by E. The minimum number of temporary variables. The question is asking the minimum number of temporary variables required to create a 3-address code in a single static assignment form. Okay, I hope you understood the question. So this expression is given to you. See the expression. The expression is A plus minus B. This is unary operator multiplied by C plus D divided by E. This expression is given to you. First, you need to convert this to 3-address code. What you need to do? You need to create 3-address code in static single assignment form. Okay, what we need to do? Create 3-address code in SSA form. In SSA form, this is what we need to do. So, first, what is the first thing you will do? Tell me. Who will be done first? What will be done first? What will be done first? See, very simple point. First, this unary operator will be done. Yes or no? First, you will do this unary operator. Agree? So this unary operator first you will do. Remember, please understand, this is unary operator. This is a unary operator. This is your minus B. Basically, this code is similar to A plus minus B multiplied by C plus D multiplied by E. So first you need to do minus B. This is the first thing to do. This is the first thing to do. First you do minus B. Then what you will do? Then you will do multiplication. This is the second thing to do. Then this is the third thing to do. Okay, yes or no? Then this will be the third thing to do. Then what will be the fourth thing? Fourth thing to do. Then fourth thing will be, this will be the fourth thing to do. Correct? This will be the fourth. And then finally, this will be the fifth thing to do. Yes or no? Then finally, okay, this will be the fifth thing to do. I hope you understood. Okay, so this is the simple idea. So let's first do this minus B. Okay, first we are going to do this minus B. Sorry, D divided by E. There is D divided by E. Yeah, okay, that is also fine, right? Okay, so everything is fine. Okay, so tell me. So first what we are going to do? Please tell me. We are going to do this minus B. This is what we are going to do first. Okay, in the 3-address code, there is a instruction. If you remember, in 3-address code, do you remember we have this instruction? A variable is equal to unary operator variable 2. This instruction is there in the 3-address code. If you remember, this instruction is there. Variable is equal to unary operator v2. This is unary operator. This is unary operator. If you remember, in the 3-address code, this instruction we have. So first we are going to do minus B. So in the T1, we will put minus B. Then what we are going to do? Okay, now this is in T1. Remember, this is in T1. Then what we are going to do? Then we are going to do this. Yes or no? Then we will do T1 multiplied by C. We will put in T2. Now this is in T2. Okay, this thing is in T2. Now what we are going to do after that? After that, we are going to do D divided by E. This we can put in T3 because you want SSA form, static single assignment form. So do not assign to the same variable more than one time. Okay. So this is what we have done. Then finally, what we will do? Then we will do A plus T1. Okay. Yes or no? Sorry, A plus T2. Because remember, this value is in T2. This value is in T2. So what we will do? You will do A plus T2. Yes or no? A plus T2 you will put in T3. And finally, you will do T3 plus. Sorry, you will put in T4. Okay, you cannot use T3. You have to use T4. Then finally, this T4 plus T3 you will do. Okay, and then you can put it in T5. So what will be the final answer? 5 temporary variables are needed. Yes or no? We need total 5 temporary variables. So how many temporary variables are needed? The answer is going to be 5. Understood? Please tell me. Is this question clear to everyone? This question is clear and the solution is clear or not? Let me know. So very simple. First, you will do this unary operation. Unary operator you do. Then you do this one. Then you do this one. And then finally you can do this and then this complete thing. Okay. So 5 temporary variables will be there. So this is your SSA. SSA is over static single assignment. This is over. We have done the complete analysis, all the gate question, a lot of practice we have done, and everything we have seen. I told you that future and past gate exam questions you can solve. In the gate exam in future, if any question comes from SSA, you can solve it. Everything covered. Okay. So please let me know, did you understand? Please share your feedback. Okay. So this video I will put on the goclasses YouTube channel. So please comment. Please like and comment. Okay. So did you understand? Please tell me. Let me know. All the students who are live, please tell me. So this is your SSA, static single assignment. This is over. Everything we have seen. Did you understand? Please tell me. Are you confident? Phi function, did you understand how to convert conditional statements into SSA, how to convert loop into SSA, how to use this Phi function? Okay. So basically every detail I have told you. Okay. Thank you, everyone.